Hello, I am Dustin. I work at Xbox Game Studios.
Hey everyone, I'm David Lee, and I'm the Game Developer Product Manager at Visual Studio.
And today, yes, clap for David. He's awesome. Today, we're going to try to prove to you that the challenges being overcome by C++ game developers can benefit you. You can get something out of the challenges that they're overcoming. And so we're going to be exploring some of those challenges today, kind of bringing you along into that experience.
Exactly. Our session is going to be a little bit different than some of the sessions you might have seen in the past few days. Well, we're going to build a game and show you different parts of game development. So for all those game developers out there at home from the future, this might sound a little bit familiar to you, but for everyone else.
Yeah, you'll be nodding right along if you're a game dev. But first, let's get some audience participation. How many of you out there are developers? You write code on a regular basis.
All right, let me see those hands.
All right. You people online, keep those hands up. Okay, now, keep your hand up if you are writing game code. Any game code people working with Unity, working with Unreal, kind of, a little bit? Okay.
Great.
Hands up if you are writing game code in C++. Any C++ game devs out there? The hands go down.
I see you.
We've got one at least. All right. And for those of us with our hands up, how many of you are writing AAA game scale code in C++? Anybody working on a million-line code base in C++? I see some people online. It's okay.
All right. Here's a question. How many of you play video games? I want to see everyone's hands up. Candy Crush,
here, right?
Minecraft.
Minesweeper, Solitaire. We all play games. We're all benefiting from the work that these game developers are putting into their jobs, right? And, game development is not all null pointers. There's a lot to it. It's got some unique challenges, some unique constraints.
Right. And for these unique constraints, AAA games have some unique constraints that are a little bit different than other type of code bases.
Yeah, it's a little different than your classic web dev kind of workflow, right? So one of the unique constraints that I learned about when I switched from web development and distributed systems over into games was that AAA games are real-time systems. What this means is that I need to be able to refresh the screen every 10 milliseconds. I don't have time for a garbage collector.
That's right. So I remember the days when I was playing VR when it first came out, and playing along, shooting arrows at bad guys, and all of a sudden my frame rate drops, and huge headache.
Right, you twist your head, and suddenly VR becomes Vomit Comet.
Your brain does not compute.
The other unique constraint that we have is that you want to play your game in a bunch of different environments. I want to be able to play on my Xbox or on my PC, on my Switch. And not all of these have managed code environments. They're not all running on VMs. What this actually means is that I need to generate some kind of binary file. I need to be able to create machine code for each of these different platforms. But I don't want the game to be fundamentally different. I don't want 11 copies of this game. I want to keep most of the game the same and just kind of abstract away some of the platform stuff. What this generally means is that we're writing the same game a bunch of times in the same code base, and that makes these games a lot bigger.
Right, games are getting bigger and bigger. Sure, some of you remember Christmas morning, you just got an Xbox, maybe for yourself, maybe for your kid, but really for yourself. And you open up Xbox, plugging that game disk, and bam, 90 gigabyte download.
Right. Why is that? Well, because you're downloading a binary, an encrypted binary. That means you can't just patch the 4 lines of code or whatever that changed. Everything in that binary has shifted around a little bit. All the symbols have moved. And so that's why those problems exist.
And that's why AAA games are built with C++.
Yes, AAA games tend to be big C++ monoliths, and this creates all kinds of unique, hard challenges, and that's kind of what we're going to explain or look at today. But I don't think everybody in here raised their hands when they said that they were working with C++.
Yeah, so pretty sure not too many of you here in the audience. And I do see, we have good majority of C++ coders online who are joining us. Let's give everyone a little refresher.
Yeah, let's just do a quick introduction back to some C++. It's not all dangling pointers in raw memory.
Yeah.
So I've done some pre-work here. I've created just the skeleton of a very simple game.
Yeah.
What game should we show them?
Well, rock, paper, scissors, right?
I like it. It's simple, it's easy, but let's expand on it. How about rock, paper, scissors, lizard, Spock? I am a nerd after all.
Yeah, let's do it.
All right, I'm also going to be demoing some pair programming. I'm going to be doing the talking, and David here is going to be doing the typing. So if you're interested in pair programming, come talk to me. All right, so David, let's just create the equivalent of a hello world program. So we need a main, right? Every program has a main in it. In C++, we're going to write int main, open close parenthesis, open curly brace, and then we're going to use std, colon, cout. No chevrons yet. Cout, and then we're going to chevron in the string hello world.
Well, we're at Microsoft Ignite. We're going to say, hello, Microsoft Ignite.
Awesome. Let's throw, \n for new line. Let's go ahead and build it and run it. And let's just make sure that we have a valid working C++ demo. Hey!
Hello. Awesome.
Not too shabby. All right, let's actually turn this into a game. So a game is going to have a player, right? So let's go ahead and get the player's move. So we're going to use auto. Auto is an implicit variable. So if you're in C# world, then that's the equivalent to var. There's other languages that have implicit variables. The auto player move is going to equal get player move, because I'm super creative. Perfect. Now we need the opponent's move, right? Let's call this auto AI move equals get opponent move.
That's super creative, Dustin.
I do like my abstractions. All right, and now let's play the game real quick. So let's get the result, auto game result, something like that. And that's going to equal game, this is the namespace. And then we're going to call a free function called play. This is a function that does not have a class around it. And we're going to pass to this function player move and AI move. Thank you, IntelliSense, for making this easier. So now we've actually got the moves, we've played the game, but we haven't told the user anything yet. If we did this, you would see hello Microsoft Ignite, and then it would sit there waiting forever. So let's change that cout at the top to print out that prompt that I have up on line 8. Okay, and now after line 22, let's go ahead and print out the player's move just to make sure that we've got it right. So we're going to say std cout, and we're going to chevron in u selected, and space, quote, chevrons, and we're going to just pass in the player move. This is overriding the OStream operator. So operator overloading is totally a thing in C++. New line, great. And did you know you can just Control-C on a line without selecting anything, and it just copies the whole line? So go ahead and paste it on the next line. Great. Now let's say that your opponent selected the AI move. In the quotes, change you selected to your opponent selected. Perfect. And then let's paste it one more time. And we're going to say you space, and then we're going to pass in the game result. All right, let's build it and run it.
All right, let's see what happens.
This is audience participation point. Aha! We have to select one. Okay, fingers in the air. Which one should we select?
Rock, I hear rock. Okay, let's try rock. We win.
Aha!
Rock beats lizard.
All right. That was a really short game, David.
Yeah.
Maybe we should create a game loop, though. Maybe we should get a little more gameplay out of this. So we're going to create a forever loop, a while true loop.
This fast already?
Yeah, it's okay. So while true, we're going to put some curlies in there and move all the code inside of that while true loop. But we need a way to exit the game as well. And so let's check to see if the player has asked us to end the game. So let's do if player move equals game : move. I forget what I called it. End game, game over, quit.
Game, move, and it's end game.
End game. There it is.
Exactly.
Got some new IntelliSense.
This is a new feature in Visual Studio 2022 for C++ that shows enumerator options.
All right,
Let's
so
do
if they've
endgame.
selected the end game, then we're going to just return 0. All right, let's give it a run. With that, we should have a game loop that just keeps playing until we ask it to end.
All right, more choices. What are we doing here? Spock, Lizard, Spock. I see a lot of
Spock.
5s.
Lots of Spock.
Okay, Spock better win.
Oh,
Oh,
no.
no. All right, one more try.
Yeah, we got to do this again. One more.
Scissors, rock,
I've counted all the fingers, and it came out to paper. Let's try paper.
All right, paper.
We lose
dang
again.
it.
Rage quit, 0. I don't remember offhand.
Paper disproves Spock.
Good to know. Well, I rage quit, and that is the end of our game. But it is a game. It is a game written in C++ because you have a way to play it, you have a way to win, you have a way to lose, and you have a way to end the game. So it's not a AAA game in C++, but it at least gets some of the ideas across. But David, that was like 10 files tops. How does Visual Studio hold up to huge monolithic C++ games?
Yeah, we made a lot of performance improvements in Visual Studio. This is really thanks to our game developer community for letting us know we need to open up files faster, we need to open up Visual Studio faster, we need to open up that solution faster. All of the feedback has resulted in effort to make Visual Studio faster.
Game devs do love our perf.
Right. So, Dustin, when you go badge in an Xbox, what are some of the first things you do?
Well, so I'm going to probably get the latest code and then open my solution and then probably go get some coffee.
Get some caffeine? All right. Well, in Visual Studio 2022, like I said before, we have improved drastically how much faster it takes you to get to code. As you see here, for example, colorizing C++ code has a 2x improvement.
If you've not tried looking at C++ without syntax highlighting, oh, you're in for a treat.
Yeah. And if it's colorized warm, that means you have opened a file before and there's indexing done for it already. That has a 6x improvement. And I know some of you out there who opens up multiple solutions a day definitely have complained to me personally about how long it takes to open a solution. We have made that twice as fast.
Yep, when somebody checks in their filters and you have to reload your solution multiple times a day, it counts. It adds up.
Yep. So what about search and navigation? This is also one of the areas that game developers have been telling us about. C++ find all references used to take a long time. Long enough to get...
Right. Control-Shift-F to do, go get some more coffee.
2 cups of coffee? All right. So C++ find all references from 50 seconds to 14 seconds, 3.5 times, and find in files. In Visual Studio 2022 is now index find in files.
Do you think we can quickly show them what it looks like now?
Yeah, let's show them. So let's go back to our game.
If you're not familiar with Control-Shift-T, this keyboard shortcut will change your life if you're working in a huge code base.
So what you see here is the new all-in-one search experience that is available in the previews. It's a little bit different than the existing search, but what should we search for?
Well, I work in quality in the Xbox org. How about we search for tests? What are the odds for a demo like this? Would I have written any tests?
As you can see here, we can go to any file and also have a quick preview
Goodness, you're looking at gtest.h. There be dragons.
All right, so that's some search and navigation. And for our Unreal developers out there, we have added blueprint support in Visual Studio. It will be available, it is currently available in 17.4 preview. However, you do need a plugin that we're working with Epic Games to be published on the UE Marketplace. But a quick sneak peek here. When you open up your Unreal Engine project, you can see your blueprint references in line with your C++ code. So no more switching back and forth with the Unreal Editor and Visual Studio.
But not everybody in here is a game developer, an Unreal developer. Are there any benefits for them?
Exactly. So, right, everyone, at least in the audience and some of our online audience, hey, this is for you too. We benchmark our performance against Unreal Engine and Chromium. And we directly target large code bases in order to improve these performance. So even if your project or solution is small, you'll reap all the benefits.
That's right. So you've just assigned a bug to me. Shall we talk about that?
Yeah, so find a bug, open up the IDE. Like, what do we do from here?
Well, one of the first challenges that I'm going to run into in a new code base especially is some of this legacy code is old.
How old?
Like written last century old.
You mean last millennium?
I think some of this code is older than some of the people in our audience old.
I bet.
And so this legacy code is too good to throw away sometimes, but the landscape has really changed over this time. I've found this copyright from '98 in one of these code bases. And
yeah. And just imagine you're building a suspension bridge 10 years ago. All of a sudden, 6 months ago, okay, some people left. We're going to have to build a drawbridge now.
Yeah, can I remove these cables?
Probably not. You don't know which cables are safe.
Is there a good reason for us to be riveting our boards together rather than using, I don't know, screws?
Let's not mess up the bridge. Let's just be safe.
So things have changed a lot. The language has changed a lot. Since C++ 98, we had 98, we had 03, we had 11, 14, 17, 20. There's 6 different versions of the language, all living in these code bases.
Yeah, and of course, C++ 23 is on the horizon.
Looking forward to it. Also, hardware has changed. Your refresh times have changed. Everything has changed. There's almost nothing that hasn't changed in these environments.
Exactly. All right, so what can you do here?
So I've got a bug, and I need to try to figure out what is causing the bug. I, being a quality person, I'm going to want to write a test for this bug. I want to elicit the behavior, the buggy behavior, in an automated way so that I know when I've fixed it.
Right. Okay, so we can just write text everywhere, right?
Well, one of the problems is that testing was not really that popular, say, 10, 15 years ago. A lot of the code was not written to be testable.
Okay, so we can't test. How about refactoring?
Well, that would be my next step. If I can just refactor the code to get it into a testable state, then I could write some tests for it. But there's a catch-22. I can't really safely refactor it unless I've got tests, but I can't write tests unless I've refactored the code. There are some safe refactoring recipes out there, but there's not that many of them. And interestingly enough, C++ is designed by specification. What this means is there's not a unified AST or abstract syntax tree for C++. This makes tooling a lot harder in C++.
Okay, so some games can be tested, some games can be refactored a little bit. But okay, what if you can't do those two? Can we use our computers to help us with?
Yeah, so I could teach the computer what buggy code kind of looks like. And this ends up being static analysis. So static analysis is kind of like doing a code review over a million-line code base, and the static analyzers are getting better all the time. Microsoft Visual Studio comes with a static analysis tool, which has recently integrated new tools for the CPP core guidelines. If you're a CPP developer and you've not read those guidelines, go home, put them in your bookmarks, and start reading.
That's your homework.
You've got homework.
All right, so static analysis. What about finding bugs at runtime?
Yeah, so I find static analysis, it says this is probably a bug. Management comes back and says that's probably not a bug. It's been like that for a decade. It's probably fine. And so instead what I do is I can turn on tools like ASAN or Address Sanitizer, and it boasts a 0 false positive guarantee, meaning that if this thing says that you've run into a bug, it is a bug. You are hitting this. You are scribbling over memory. You are buffer overrunning. You have hit a problem, and you're hitting it at runtime, guaranteed.
All right, shall we show everyone how to turn it on?
It's surprisingly simple. You might think that you have to do all kinds of weird stuff with your build scripts, but let's say that I've got a project, and I just want to see if it works fine. I just right-click on the project, on the thing that's going to run. I go down to Properties. I go to the C++ General tab, and then down at the bottom, I think second from the bottom, is the Enable Address Sanitizer. And just like that, I can turn on ASAN and run my tests.
Fly? Okay. And do you think it will work?
I think we could get it to work, but we would have to change to x86 currently, unless they fixed something really recently.
All right. So let's move on to our next topic.
All right. So we've talked about changing code, getting a test in place, hopefully, or at least running some kind of static analysis or dynamic analysis. The next thing that we want to do is...
Well, next brings us into the Interloop. Dustin, tell us what's the difference between, let's say, web developer Interloop versus a game developer Interloop.
Well, so C++ is a compiled language, and in C++ we see the compiler and the linker. One of the interesting things is that CPP files, in C++ you have CPP files and header files.
Hey, tell us a little bit about header files.
It turns out header files are lies. They're not things at all. All that really happens is that when you pound include a header file, it is literally copy and pasting that code in place. So we started out with our Hello Microsoft Ignite. You could write that in 2 lines of code. After the preprocessor runs, how big do you think that file is?
Okay, our code that we just wrote was maybe like 20-some lines. Let's be safe and say maybe 100 lines?
If you had guessed 65,000 lines, you would have been a little closer to our Hello World program. And so we have thousands of CPP files, and these are all multiplied by the number of headers that you're including. You're including hundreds or thousands of headers into each of these CPP files. And so, as you can imagine, looking at a 10,000-line CPP file looks pretty gross, but the compiler sees a 10 million-line CPP file instead.
Just to give you an idea, here in a unspecified AAA game project, this is one of the files.
Right
and
at the top.
260 includes before your written code even begins.
Yep. And let's look at how long this file was. Oh, this file's only 19,000 lines long. So as you can imagine, there's a lot of work going on in the CPP compiler.
Yeah. So there's a lot of these header files. Maybe we can, I don't know, pre-compile them?
Indeed, this is one of the solutions that game devs are using, is pre-compiled headers. The idea is to take the headers that are included in lots of different CPP files and compile them once. Because normally, if I have 2 different CPP files that both include the same header, they each get a copy and they both compile both the header. And so there's a lot of duplicate work going on. If we can create a PCH file or pre-compiled header file, we can reduce the duplication of that effort.
Okay, so we mentioned legacy code before. What if we can't use PCHs?
Yeah, so not everything can go into a PCH file. Not everything should go into a PCH file. The other way that game developers are getting around this and reducing the amount of duplicate effort is by jumbo or unity building their projects. What this means is it's taking advantage of that pound include, and it is going to copy and paste a bunch of CPP files into one CPP file. And so all of the headers from those 10 or 12 different CPP files that you included also only get compiled once because of the pragma once. But I forgot to mention that PCH files have a natural extension. If you're able to move on to C++20, you have modules, and modules do the same thing as PCH files, but more and better. Our same Hello World program, instead of being 65,000 lines, is 3 lines of code.
That's a lot of less code. Okay, so we have Jumbo builds and Unity builds. I know you have a lot of great machinery over there in Xbox. How can we leverage that?
For sure. So even if I have all of these Jumbo builds, I still have 1,000 things to compile, but each CPP file is a contained unit. What that means is this is a parallelizable problem. I can actually send all of these CPP files out to all of the machines around me to do the compiles at the same time. And this distributed compile can be done with a tool called Incredibuild. And Incredibuild has integrations with Visual Studio, so it happens right in the IDE.
Exactly. There is a very useful extension that Incredibuild has made for Visual Studio. Okay, so builds are long. How do we diagnose this?
Yeah, so if you are into that kind of thing, Visual Studio also has put forth build insights. It's a way to actually emit messages during the build to see what's taking so long. And it turns out that, oh, you've got some weird template file that happens to be taking 3.5 minutes. Doesn't matter how many machines you distribute the build across, that's going to be your bottleneck.
Okay, so now we built this. Are we done yet?
So it's compiled, but we haven't linked it yet. And linking is not something that a lot of people see unless you're working in C++. So the compiler produces these OBJ files, these object files, and the linker stitches them all together. And if you're not careful, any change to any object file, to any file, causes a relink. And this means that it has to stitch all of these things together. If your minimum time is 3 to 5 minutes of linking, that kind of puts TDD off the table.
Tell us, what is TDD?
TDD is test-driven development. So for the agile folks out there who are using TDD, good on you. We're trying to get people to think about these kinds of things in game development.
So speaking of link time, this is another one of the areas that we really listen to our game developer community. As of Visual Studio 2019 toolset, we have really dialed down how long it takes for the linking to happen. So there are some of you out there that are still using VS 2017. I see you. Please join us in Visual Studio 2022 as soon as you can. You'll get a lot of improvements and less time to drink coffee.
It's true. My caffeine addiction is getting the best of me. All right, so I've made my changes, and I want to see, they work on my machine. Do you think it'll work on the farm? Do you think it'll work on your Xbox?
I sure hope so, right?
So normally what we do for this is continuous integration, or CI. Believe it or not, CI is fairly new to the games industry. Everything becomes harder when you're working at this scale.
Okay, so CI involves syncing, building, running some tests. What are the big differences?
So like this example shows, what this picture shows, in case you can't read it, is copying 9,004 out of 10,718 files. This is not the full repo. This was me getting the latest from like 2 weeks ago. So if I were to try to sync the repo at whatever change list is current, that can take hours. These repositories, these databases, or these code repositories can be more than 1 terabyte in size. And so to start with just a clean machine and download your Git repo is not really a solution for game developers.
So what do game developers do instead?
What they tend to do is use stateful machines. They don't clean out the machines every time. They have a dedicated hardware, and they sync to some CL, to some change list, and then they get the deltas from there.
All right, we sync the code. Now we got to build it, right?
Yeah, and it's all the same problems that we mentioned before, that we need to be able to build these thousands of files. But there's an extra little hiccup. We don't want to build it on just PC. We want to build it on PC and Xbox and Steam and all of the other platforms. But we also want to be able to build it in our debug mode, in our profile mode, and our release mode. This can easily become 50 to 100 different builds. And so the idea of being able to distribute these builds across a bunch of build machines becomes even more important.
All right, so once again, what do game developers do differently?
Not a lot different here, other than they have to be able to use something like IncrediBuild to distribute the build across the farm.
Okay, so I'm kind of getting a sense here that, game developers do things differently. What about tests?
Well, of course you have tests, right, game developers? That's a thing now. So game developers are getting into writing tests, and a lot of them are slow, flaky, end-to-end kind of tests. We're trying to get people to start writing some unit tests as well, but a lot of these tests take a long time to run, and they're flaky. There could be thousands of tests. They could take hours to run. And so it would be great if we could just push these tests to a bunch of other machines. But of course, there's a catch. There's always a catch. I now have to move this giant build to all of those other machines so that they can run the test. These are not megabytes. These are tens or hundreds of gigabytes that need to move to all of these devices. And so distributing builds is its own unique challenge in game development. And let's say that I want to work on a CI, and I don't want to wait 6 hours to see if my CI is green or not. I may only run the fast tests for my check-in and then run the slow tests on a nightly basis, so that perhaps, at least if we catch one of those things, it's only a day old, but I'm not waiting 6 hours and then seeing if I can undo the changes or fix the problem.
All right, so I think we give the audience a glimpse of what a game developer workflow is like, right?
Well, and so naturally at this point, after you run all the tests, you merge, right?
Yeah, so it's time to check in and merge.
Yeah, we did that already.
What do you mean?
So it turns out waiting 6 hours for a CI is just too long. And so the normal strategy in the games that I've seen is you merge and then validate. And so if you broke something, it's already distributed to everybody else. Gives you the advantage that you can at least roll out a hot fix real quick.
All right. So please give us feedback about this session. To those of you out there who are not game developers, let us know what inspires you, what resonated with you.
And for the game devs out there, I've done my best to represent the community. I'm still fairly new to it, so I've probably missed something. I've probably said something wrong. Please let us know, what is the big challenges that you're running into? What are some unique and cool solutions that you've got that I haven't shared today?
Exactly. We did miss a big part, didn't we?
Well, which part was that?
Debugging. We want to know here at Visual Studio how your debugging experience is when it comes to game development. We want to know what are some challenges, what are some things that you could wish could be better, because we know you're not debugging your release builds out there.
Yeah, trying to debug an optimized build is an experience all its own. But because we need to be able to keep that frame rate kind of going, and we're running into, say, threading issues or real-time issues or things like that, we can't just run a debug build. We might be waiting 20 minutes to get past the loading screen.
Exactly. We want to know more. Tweet at me. My Twitter handle is @CPPPM. Tell me about all your problems.
We've also got a direct link there, aka.ms/ignitegamedevsurvey, and that will lead you to our page. And please provide us feedback. We are listening.
Great. So now we'll open up for questions.
All right. Thank you very much for your hard work. We appreciate that. Got a question online from Travis, who is asking about the size of the repo that you were using. When you had those benchmarks about opening up Visual Studio, you had the cold and the warm. How big was that repository?
That repository was benchmarked on Unreal Engine 4.27. So it's a giant repo. It's also publicly available. So if you're interested, go to Epic Games and try it out yourself.
So that is the Unreal Engine demo repository. Do you have a ballpark of, is that like gigs or hundreds of megabytes?
It's gigs, if not hundreds of gigs.
I think it's gigs of source code. Normally, when you get to the hundreds of gigs or terabyte of size in repo, it's because of content. So raw content, raw assets, that takes up a lot of space. And for reasons, code and content tend to be in the same repo.
Okay.
Exactly. And also, we also do benchmarking on the Chromium repo, which is 100,000 files big. So we're looking at these big repos to do our benchmarking.
It's interesting that you point out the difference between the assets, the movies and the models and all that kind of stuff, but you also mentioned million lines of code. Some of these AAA games do have a million lines of C++.
Heck yeah.
And then Visual Studio has to parse all of that, and even to go and decide that that's a keyword, that should be pink, and that's another keyword, and that should be blue.
Yep.
It has to make those decisions over that.
Yeah, for sure. And that's the colorization that he mentioned, right? Is you open a 20,000 line file, and at first it's text, and then the IDE kicks in, and it's going to turn all that text in, like it has to parse it in real time.
And then does it have to hold that in memory and think about all those different symbols? Because you can do things like go-to definition. It needs to not just say, that's a word I recognize, but it has to think about the larger context.
Yeah, so there's a lot of speed-ups when you first open up a brand new solution, for example. But we do store some of those indexing information so that when you open up a file that you previously opened, it'll go even faster.
Right, and it's more than just the CPP file you're looking at, because all of those includes could have macros in them that could actually change what you're looking at from a function to a precompiled or to a preprocessor macro. So in order to actually give you the right syntax highlighting, it has to parse the entire .i file.
Okay. And then I had one last question before we take off the end of the day here for myself. As someone who started in C++ in 1990, 1992, I've heard that it's different now. And I may have some biases against C++. I'd like to hear from each of you about what my 30-year bias against C++ should be, and then maybe I'll get into the new things, because you're like, auto. I'm like, auto? What's auto? So why don't you go first?
There are so many features that have entered C++ over the recent decade or so that have made C++ type safe and memory safe by default. So if you're using raw pointers, that's probably what people remember, right? New, don't use new anymore in C++. If you're using delete, something has probably gone wrong. We've got unique pointers. We've got shared pointers. These are using RAII, or resource acquisition is initialization, a terrible name for an awesome concept. But this means that it can handle the cleanup for you automatically. And so things like that, and constexpr, these are all unique and interesting features that prove that you can't have undefined behavior and will prevent you from making memory leaks. So these are all new features that have come in since the 90s for sure.
Very cool.
I think, I also think some of the cool things that are happening in the newest versions of C++ 20, like we mentioned before, C++ 20 modules, that will really save on compile time. And I know for all the game developers out there, or if you have a large code base, look into it. I know the change might be hard, but there's always cool things on the horizon when it comes to C++.
Very cool. Well, thank you both for your time and your hard work, and for closing out our Microsoft Ignite developer track. Appreciate you both.
Yeah.
All right, big hand.
Thank you.
To the gentlemen for their hard work. I want to encourage you, of course, to take a screenshot there. You can tweet them on Twitter as well as fill out that session. And then remember, of course, if you put this session in your session catalog, please do fill out the forums and the surveys, because we look at them all. And I want to just say, on behalf of all of us, the hard work, Chloe and Molly, our friends doing our ASL translation, and all of you for sticking around. This was an experiment. If you like it, tell us. Thank you very much. Appreciate you. Bye-bye.
All right, and we'll be around if you have more questions.
All right.